So it says, give possible measures for angles B and C if ABC is isosceles. So remember, isosceles means two sides are equal. So if angle A is 40, let's say this is 40, you have some options for what the other angles could be. If two of them are equal, there could be two 40s. And that means B would have to be 100. They have to add up to 180. Or, again, that's not drawn to scale. That's obviously not a 100-degree angle there. You could have said this is 40 and had these two angles be equal. Be isosceles, remember two angles have to be equal. So 180 minus 40 is 140. Divided by 2, they both could be 70 as well. But the key is, if it's isosceles, two of them has to be the same angle to be isosceles. Because if angles are equal, sides are equal. B, if it is a right triangle, so let's say B is a 90-degree angle, A is 40, C would have to be 50. Again, it has to add up to 180. Question number 2, for each set of angles, decide if there is a triangle whose angles have these measures. If you get stuck, consider making a line segment, use a protractor. Okay, we haven't done much with that. Basically, can you draw a triangle? Okay, can you draw a triangle with 360-degree angles? Yeah, that's an equilateral triangle, so that would be fine. How about 90, 90, and 45? Why not? Yeah, it's over 180, right? I mean, you could try to draw it, 90-degree angle, 90-degree angle. You know, what kind of triangle are you going to get there? No, it's not possible. How about 30, 40, 50? It doesn't equal 180. 45, 45, 90? Fine. 120, 30, 30? Fine. So it should be 3 of them. And first step would be, do they equal 180? That's a great start. If angle A is obtuse, so obtuse means more than 90, so here's A. Remember, that means more than 90. Can B or C be obtuse as well? So is it possible to have two obtuse angles? Why not, Gabby? Yeah, you can't make a triangle. Cannot make a triangle. If you had two obtuse angles, those two angles would be greater than 180 by themselves, which doesn't make sense, right? Question 4, describe the transformation. Describe the transformation. Well, if I just look at one point here, 1, 2, 3, 4, 5, 6. Slide 6 to the right, and 1, 2, 3 down. 3 down. I don't know why I wrote it twice. So that's a slide. And then specify how far. What do you got for B? Reflection. It's going to be reflection across this line to be specific. Reflection across this line. Whoops. Right there. Reflection across a vertical line, however you'd like to phrase that. C? Which way? Yeah, it looks like counterclockwise. How far do you think? Exactly right. Rotate 90 degrees counterclockwise. We're actually going to get into more scale factors here. This is kind of a preview for Unit 2. But anytime you have a number less than 1, your figure is going to get smaller. Anytime you have a number bigger than 1, your figure is going to get bigger. So the figure that you drew should be smaller. Okay, should be smaller. So I'm going to start with AC. It is 6 across AC, so on my drawing, how far across will it be? What's half of 6? 3. So start it wherever you want. And those are new points, so they're going to be C hat and A hat. And then it's hard to measure diagonally, so I like to say, all right, 2 up and 2 to the right. We're going to do half of both of those. So what's half of 2 up and 2 to the right? Half of 2 up would be 1 up. Half of 2 to the right would be 1 right. So I'm going to go 1 up, 1 to the right. So there's my new B. And that is 1, 2, 3, 4, 5, 6 up and down again. So I'm going to go 3 up and down. That's half. 1, 2, 3. And then it's just a matter of connecting. The dots should look exactly the same. Half as big.